Hello everyone, welcome back to my YouTube channel Code Logic. So in this series we are seeing the faang interview questions. So in our previous videos we have seen some of the questions like finding the middle element of the linked list and detecting the linked list if loop is present inside the linked list or not. So in this video we are going to solve the one of most asked question. Okay. So in this video we are going to see remove end node from the end of the linked list. So yeah, without wasting any time, let's get started. So we problem statement is like this. So given a linked list with a number n, find the nth node from end of the linked list and then delete it. Okay, we have to find the nth node from the end and then we have to delete it, and then we'll have to return the head of new modified linked list. Okay, so we have given one example here, so you can see 1 2 3 4 5, this is our linked list. Okay, and we have to delete second node from last, so second node from last is 4. Okay, now output will be like this: 1 2 3 5. Okay, we have to delete this now. Okay, and then expected time complexity is of n, and auxiliary space complexity is of 1. So that means we can iterate over this uh, linked list, and auxiliary space is of 1. That means we are not allowed to use any extra spaces. Okay, so we'll see there are two approaches, we'll see both the approaches. So this is first approach, this is a naive approach. So we have to calculate the length of linked list first by traversing it, and then again we have to traverse the linked list and then delete the length minus nth node. Okay, so suppose we have a linked list here. So this linked list have 5 elements, right? Then first we have to traverse the linked list to calculate the length. Okay, so in one iteration we are able to find the length, that is 5, and then we have to remove this node, that is last second node. Okay, so to delete that we'll use length minus nth node, so length minus n, so 2, that is third node. Okay, so after 3 nodes we have to delete this node, so we'll move 3 nodes from here, so this will be our head node, and we move 3 digits from here, and then we will be reaching at this point. Okay, so head will be pointing here, then we'll have to delete this node, so we'll directly point here, and then we'll remove this linking, and then we'll delete this node. Okay, so this will be our first approach. So there is another better approach. Okay, I'll show you now. So this is the second approach. In this approach, first we have to use two pointers. Okay, so fast pointer, slow pointer, this kind of thing. So first we'll start iterating a linked list up to n nodes. Okay, so we have 5 nodes, then and we have to delete the last second node, so we'll first iterate the 2 nodes. So fast pointer will be uh, moved by 2 nodes ahead of the slow pointer. So when we have the difference of n nodes, then we'll start another pointer from head, that is slow pointer. Okay, and we move both the pointers simultaneously, so a fast pointer and the slow pointer will have a gap of n nodes. Okay, n nodes gap will be there between slow pointer and fast pointer. When fast pointer is at the last node of linked list, end of linked list, okay, then the slow pointer will be at nth node from the last node. So when fast pointer is at end end of linked list, then the slow pointer is at the our nth node from linked list, then we just need to delete that node. Okay, now we'll see the dry run of our code first. So you can see we have a linked list here, so we'll have 2 pointers, so fast pointer, and then we'll have another slow pointer. Okay, so initially we'll start iterating with the fast pointer, so fast pointer will be pointing here. Okay, so we have to suppose remove a second last node, remove second last. Okay, then firstly we'll move fast pointer by two digits. Okay, so first it's at pointing at 10, then we'll move it to the 15. Okay, and then again we'll move it to the 20. Okay, so now you can see, so fast pointer is pointing at 20, so we'll remove this now. And now slow pointer will start with the 10, slow pointer will be at here. Okay, so now we'll move both the pointers simultaneously. So fast pointer will be at 25, at that time slow pointer will be at 15. Okay, after that when fast pointer is at 30, the slow pointer is at 20. Okay, so you can see slow pointer is at 20 and fast pointer is at 30. Okay, so we have to remove this 25 number node. Okay, so when uh, fast pointer fast pointer is at last node, is at last node. Okay, so you can see 30 is our last node. Okay, at that time remove the second node from the linked list from slow pointer. So what I am saying is, so we have slow pointer here. Okay, then slow arrow next equals to slow arrow next arrow next. Okay, so that means slow arrow's next pointer will point to the this node directly. Okay, this is how we will break this linking and this linking. Okay, and then here we'll delete the node, delete slow arrow next. Okay, so yeah, that's it. We'll start with the coding part now. So now you can see I have written some code here. So this is our class node, which will have two parameters like data and next pointer, and we have one constructor here which will take a value as a data, and then it will initialize these variables. Okay, so after that I have written some methods to print a linked list. So in our previous videos also uh, I have shown how to print the linked list. So I'll try to provide that link in the I button. Okay, please watch it if you are not watched it. Then we have another method here to insert the data at the front of linked list. So video on this method also I have created already. So I'll try to provide that link in the description also. Now you can see inside the main method. So firstly we have created the linked list here from array. Okay, so I have also created a video on the how to create a linked list using array from array. So I'll try to provide that link also in the description box. Okay, and then we are just printing the linked list here before deleting a nth node. Then we have created one position variable, and then we have written one method here, remove n node from the linked list, which will take two parameters, our head of linked list and then position. Okay, now we'll start implementing this method. So first we'll check if head is exactly equals to null or not. If head is null, then we'll return null from here. Okay, after that we'll create two pointers, node start, slow pointer. Initially it will have null, and then fast pointer, it will contain the head node. Okay, Now we'll start iterating while position minus minus. We'll move our fast pointer fast equal to fast arrow next. Okay. After that, when as we have speaked earlier, so we have to maintain the n nodes difference between slow pointer and fast pointer. So after that, we'll assign here, after this while loop, we'll assign slow pointer with the head node, and then we'll again start iterating inside a while loop. So while fast arrow next is not equals to null. Okay, we'll iterate over the loop. So what we are going to do is fast arrow next equals to, sorry, fast equals to fast arrow next, and slow equals to slow arrow next. Okay, so when the fast pointer is at the end of linked list, that means fast pointer will be at last node of linked list, will came out of this loop. Okay, now we have to delete the node which is next to the slow node, slow pointer. Okay, so to do that, we'll create a one temporary node, node start temp equals to slow arrow next. Okay, so this temporary node we have to delete it. So before deleting the temporary node, what we are going to do is, so first we'll update the links slow arrow next equals to temp arrow next. Okay, and now we'll delete the temporary node, and in the end we'll return the head node. Okay, so you can see here, first we have printed the linked list before deleting the node, and then we have printed it after deleting node. Okay, now we'll run our code. Okay, so you can see here, this is our previous linked list, and we have passed position as 2 here. That means last second node we have to delete, so and that is the 35, and in the next line you can see there is a no 35 element present. Okay, so this is how you are going to delete the nth node from end of the linked list. Okay, so yeah, that's it for the video, guys. If you like the video, please like, share and subscribe. Thanks for watching the video. See you in the next video. Till then, bye bye.